Hi guys, today I'm going to talk about new location APIs in Android. So how many of you have an idea of Android application development? Little bit. Okay, great. So what do you think about location APIs? Have you tried working with location APIs on any platform? Yeah? Okay, what's your experience with location?
Current Google location which I worked, that was not giving me perfect results. As in, it was showing me Bangalore when I was trying it in Goa. I don't know how.
So how difficult was it to integrate, and what was the experience like? When did you do it?
It was a direct method call. So I included the ejects and then it was working.
Okay. Anybody else? Location? Anybody has worked on location before? No? Okay. So today I'll try to talk about the new location APIs in Android. So a bit about myself. I run a small Android startup in Bangalore, an organizer of Nitrodroid, which is Bangalore Android user group. We are one of the biggest Android user groups in the world, and I've also created this app on the Play Store called Sky Recorder. So in case you're interested, join us at blrdroid.org. We meet once a month and we discuss everything in Android and so on. And so most of these slides are from Google I/O. How many of you have heard of Google I/O? It's Google's yearly conference. So there's a video, a very nice video on location API. So in case you're interested, go ahead and look at that. Okay, so here's the problem with location APIs, right? A lot of you are getting started with Android application development and might have questions on how to implement location into your application. If you're building a very simple application, you might have questions like, this time last year, location was a very difficult problem to solve, right? So there are so many different things you can do with location. So there is GPS. How many of you know what GPS is? GPS, more or less everybody, right? So you get very accurate location of a person outside, outdoors using GPS, right? But lots of problems with power consumption. Like you've seen, if you use Google Maps for more than 5 minutes, the phone starts heating up like it'll melt your body, right? And the coverage is good, but inside, as soon as you enter a building, GPS starts to fail, right? Have you noticed that? So there are lots of problems with GPS, and implementing GPS in Android is relatively difficult. Okay, it was very difficult. Then there is Wi-Fi. How many of you knew Wi-Fi could be used for location? Okay, a couple of you, right? So in case you have used apps like Foursquare or Google Maps, they prompt that you should turn your Wi-Fi on. You get better geolocation, right? So you can use Wi-Fi for geolocation as well. So Wi-Fi is also a good thing, but again, it takes a relative amount of power. The accuracy is not that good, and the coverage is also not that good. So Wi-Fi is really good inside a building, right? But as soon as you exit the building, you go outside a building, the location is very, very bad. Again, there is cell tower geolocation. How many of you know you can get geolocation or your location from a cell tower? Couple of you, okay? So what happens is when you use a cell phone, there are multiple towers that connect to you. So using those towers, you can get an approximate location for yourself, right? This takes very less battery because the towers are doing most of the work, but it's not that accurate. But wherever you get cell reception, you can get your location. Okay? And lastly, there are many sensors. Sensors like accelerometer, gyroscope, barometer, and so on. So there are so many things that you can do with location. But as a developer who's just getting started with Android, right, it's very difficult to know how do I get started. There's so many things to do. Some work very good indoors, some are good outdoors, some are very good with battery life, but they're not really accurate. And sensors, I don't even know how to get started. So lots of different things, right? So that's the problem with location earlier this year. And as an Android developer, if you're making an app, you have to factor all of those in. So this looks like a very complex diagram because it is a complex diagram, right? This is what you had to do before. So let's say you want to get GPS. So you would use something called GPS location provider. Something very complex, right? You use sensors, go into a sensor manager. Then Wi-Fi goes into a separate network location provider, and cell goes into a separate network location provider. So if you want to use an application which uses all of this, Like if you want to build a Google Maps application or an application which gets good location, you have to use all of these different things. But there are so many different things that you have to use. You have to use sensors, you have to use this, that. It's very difficult to get all of them and to get like accurate data. Right? And most of us don't even know how sensors come into this picture. Right? Sensors are very weird. So why do you use accelerometer or barometer? Like those are like big questions. So let me tell you a bit more about sensors and how they can be useful, and what Google has done this year to improve geolocation. Okay, first thing is accelerometer, right? So whenever you turn your phone, the accelerometer is basically used. Same with gyroscope and compass, right? These are all sensors. When you move your phone, it automatically gets activated. Okay, and there's barometer, which also determines how high you are. So how are these useful? So I'll give you an example of how these are useful basically. So let's say you are inside in this location, right? I use geolocation, some kind of geolocation, maybe Wi-Fi or GPS to get your location, and you know that you're inside this hotel right now, right? Now typically what happens is you would need to check every 2 seconds or 3 seconds for the geolocation. Now if I have not moved from this location, I have not traveled a long distance, why should I check again, right? I have to go back to GPS, I'll waste battery life, I will waste like lots of different things. So why should I do that? Now where the sensors come in, sensors can tell you if you have moved or not, right? Have I been sitting in the same position? Like for example, all of you have been sitting and your Android phones are on your desk or in your pocket. So the phone automatically knows that you have not moved. So instead of going for the GPS again, it will basically return the original position that was there when you were sitting in your seat for the first time, right? That way you can save on battery life. Okay, is that clear, or does it look too complicated? Just an idea, right? Your sensors can tell you whether you have moved or not, and basically on that you know whether I should use GPS or what I should use. Okay, so before this year, lots of problems, like I said, like power was a big problem, accuracy was a problem, and you had to use lots of different APIs, like you had to use GPS, you had to use Wi-Fi and so on. So Google tried to change this by, first goal was to reduce power consumption. So if you're using an application, you won't use that much power. Second was the accuracy. The accuracy should be very good, because if I'm using GPS and I'm inside a house, GPS doesn't work. So all those different things are a big problem. Google tried to, kind of fix those problems. And also expose cool new features, which I will talk about. Okay, so this was the situation before, very, very complex and very difficult for people who are getting started with Android to, cope with. Google changed it to something like this, which is very, very straightforward, right? So you have a hardware components, you have GPS, you have Wi-Fi. You don't have to worry about that anymore. Okay, you have platform components, okay, like stuff that interacts with the hardware, like how it interacts with GPS and so on. In the new version of the API, you don't have to worry about that also. All you have to worry about is something called the fused location provider. Okay, it's fused. It basically knows all the sensors, all the GPS, Wi-Fi, all the different things that you have, and it gives you one kind of output, like a fused output. Okay, very, very simple. Just go to fused location provider, it'll give you all the details. Location automatically without you having to write a single line of code, right? You step out, it will go to GPS. Okay, then if you're using GPS for a while, it will know that okay, this guy is not moving that much, maybe it's in one position using sensors. Then it will say okay, for the time being I can use cell triangulation. So it saves on battery, it saves on, it gives you high accuracy, and you have to write much less code. Literally copy paste this and you're set to go. Okay, there are some cool things, like if you have an application like my application, right? So where I don't require continuous GPS or location address, all I need to know is the last GPS location, like a relatively accurate GPS location. So all I have to do is write that line called location is equal to mLocation client.get last location. With one line of code, you can get the last location that the user was in. Okay, so I can get like a relatively accurate, like the street name and so on. Okay, without writing any code. One line of code, you get the location. So when would you use get last location? How many of you have seen Google search on the mobile phone? When you start that, it asks you, like, do you want to share location? Okay, when you do that, all it does is use get last location. You can see that it doesn't use the GPS at the top at times because it's just one line of code. So in case you're building an application, right, just use this get last location. Of course, if you require frequent updates like the Google Maps app, then you have to keep on polling for data. Right? Any questions? Okay. So use location provider. So there are 3 different modes. If you want a very high accuracy mode, typically you would get asked for the data every 5 seconds. The power drain per hour is 7.25%. Okay, and the accuracy is 10 meters. If you have an app which requires very high accuracy, use this mode. In case you require something which is not that accurate, like balanced power, it takes 0.6% of battery life. Okay, so for most applications, this is more than enough. If you want to get like one-time power, like one-time location, you'd use the last option, no power. That takes less than 0.1% battery life now. Okay, so without 0.1% battery life, you can get like, accuracy to about 1 or 2 kilometers. Okay, the next cool feature that they have introduced this year is geofencing. Okay, how many of you know what a geofence is? Any idea? Okay. So geofence is like a virtual circular square fence basically, polygonal fence around a point. Okay, let's say you're building a restaurant app and you want the users to automatically start the app as soon as you enter a particular area. Okay, so let's say I have a very famous restaurant and whenever the user is near my restaurant, I want to give them deals. Right? What is the 10% discount, 20% discount, so that they come to my restaurant. Okay. So before this API, it was very difficult to do that because you have to continuously ask Android, right? Where is the location? Where is the location? Where is the location? It's very difficult. It takes a lot of battery and again, it's not very efficient. So the new API is called geofencing. With a couple of lines of code, you can specify a fence, a virtual circle around your area of interest, and as soon as you enter or exit the area, you will get, your application can be invoked. Okay, your application will get called. So again, this is the code for that. All you have to do is create a geofence. Okay, you tell it what kind of alert you want to set, like you want to enter an area, you want to exit an area. You give the latitude and longitude of the point of interest, okay, like a restaurant or whatever. Okay, and you give the radius, right? If you want to launch a Goa app as soon as you're entering Goa, you can do that. Right? A very simple app, right? You're building a like for your college project, you can build a like Discover Goa app. Right? Why wait for the user to launch the app? Because it's very difficult, right? The app might be on the phone, but the user might never launch it. So as soon as the user is near Goa, you can ask the app to launch itself. Okay? And you can do all kinds of different things. You can have, even if your app is sleeping, you can wake it up and do that. So all this code is available, so I'm not like stressing on it. And so there was an older API called Add Proximity Alert that took about 8% of the battery in 24 hours. The new one takes 2 or 3% of the battery. So even if you have it switched on all the time, it takes like 2% of the battery, which is not much. And the last thing that we'd like to discuss over here is activity recognition. Okay, so the new location APIs also provide you the option of detecting what the user is doing. Okay, so this is really helpful in fitness applications where you want to know if the user is sitting in one place, or he's walking, or she's on a bicycle, or they are moving a vehicle. All of that can be done automatically. Right? So this is built into every Android phone using sensors like accelerometer and so on. You can know if the user is walking or biking or whatever. So how is this done? Sensor readings can be taken. So basically when you're sitting in one place or you're walking, right, the phone vibrates in a particular pattern. So Google has understood that pattern and it knows that you're walking and you're not running. Okay, in a car, the phone vibrates on a very consistent mode. So Google now knows that you're in a car. So how is this useful? You use this app called Endomondo on the Android market. you start the app, it will automatically know if you're walking, if you're running, if you're in a car, and so on, right? So if you're in a car, it automatically deactivates itself because it's about an exercise app. So if you're walking, it will automatically calculate the amount of calories based on your speed and so on. If you're running or if you're cycling, it will switch to cycling automatically. So all this is done in just like 1 or 2 lines of code, basically. You don't have to understand the logic of how Google is doing it. So again, couple of lines of code, just 1 line of code actually. All you do is new activity recognition client. You just declare that and you receive callbacks. Okay, and again, you can trigger this app even in the background. If your application is not in the foreground, you can ask your application to start whenever the user is walking, right? If you want an app to start, users are not like consistently switching on the app, but let's say you want to build a fitness app. As soon as the user starts walking, find out number of calories, right? Consistently. You don't have to see the app in the foreground. You can still do this using this code. Again, 2 or 3 lines of code. And finally, like, how is this API available? Typically, Google has 2 or 3 different ways of launching new APIs. One is a new version of Android. Right? So if you have a new version of Android, not everybody will have access to those APIs, right? Because very few phones get updated to the latest version. But this is part of something called Google Play Services, which is with the Play Store app that you have, right? All of you have the Play Store app, the Marketplace app, right? So Google includes this in the Play Store app, so it gets automatically updated for everybody. That way, even if you have an old phone which is running 2.2 or 2.3, you can use this API with this phone. So again, you can use it, it's backward compatible to Froyo, and it uses Google's latest data model. So Google is constantly updating these algorithms, right? If they find a better way of finding out, using lesser power, without you even knowing it, Google will update these. So your app is getting better and better over time. Shorter release cycles, Google automatically launches it without everybody knowing, so it gets better on a very short basis. So every 5 or 10 days it gets updated. So that's it about the new Google Play Services location APIs. Using this, you can create really awesome applications in a couple of lines of code. In case you're interested in building those applications, just meet me. I'll be happy to guide you in, getting location or getting periodic locations. Right? Any questions? Yes. Okay. Yeah. Yep. Sure, yeah. Yeah.
Now, what if there are many people using the same app? How will it detect which sensor does it or which shoe does it supposed to detect or something?
Okay, so that's a little different. So that sensor is you connecting to a particular sensor. So these are all in your phone.
Yeah, but they're still using it.
Sure. 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 So what happens is, so for some things like how fast they are walking, they use this sensor with the foot sensor. But for geolocation, they're using the phone. So for all the users connected to that phone, right? For all the users using that device, the location is the same. Okay, but the how fast they are walking is based on the sensor in your foot. Yes, yes. That's a more complex integration. We're taking some from this, some from somewhere else. Sure. Any other questions? No? Okay. So thank you guys. And if you have any questions for integrating location, just let me know. I'll be happy to help you. Thank you.